All right, we are going to be considering a question under function, like differential calculus. So a question, a function is defined for x is an element of R by D. So this function can be written as y into bracket x equal to 6 plus x4 plus sine of x. So this is a function. The function is just a variable y that is depending on x. And if wanted to actually differentiate this kind of function, it means that we are not defining the y with respect to the x. That is how y is changing with change in x. So which is going to be, because it's actually made up of individual terms like 6 plus s squared plus sine 4x, we solve it individually. We differentiate individual term here and then we add them together. And this term here is called constant. This one is called power function, and this one is called trig function. I was explain what individual means. So this one is gonna be what the differential of 6 with respect to what 8 plus the differential of the power function is x squared with respect to x was the differential of this is actually two functions together. It's made up of the what? It's trig function, which is sine, and then the power function is 4x. And the power function here, the power here is 1, the power here is 2. So this is like a function of function. It's not just only one function, it's trig function and power function together. So, but in order to get the differential of f function of x, we need to differentiate individual term. And to differentiate individual term, there's a thing that we need to know here, which is called the standard derivative. We are going to explain the individual term that made up of the whole questions. So if I draw a tabular form here, then we have now I told you this spell function of x can be written as y just for a kind of a deep explanation for you to actually know what I'm using. That I'm going to use y variable y because it's something that we use every time the y is given. So it's the same thing. So now if I write function of x and if I write y function of y is function of x is then as x function of x. So now y function of x that the first thing is we have the type of function that we usually have or the type of variable that we usually have is constant. Constant is not a variable, it's just a number. It can be between 0 to infinity. And in first the case, we have 6 here. So whenever you are differentiating constant, we take it to be what is zero. That's that. Then we have the power function in which your power can be any number, x is power n. So in this case, we usually consider the coefficient as well. It's very, very important. That value introduced as what? A. Coefficient A. And the power function can ranges from 0 to 1 to infinity as well. So in differentiating a power function, which is in order to find the y with respect to the x, you are going to multiply the power with the coefficient. So this is going to be what? A multiplied by the power, which is n. Power is n. So, and then x is the power. N minus 1. You remove 1 from the whole power. So you are going to multiply the coefficient with the power. Then remove 1 from the power. So that's how we differentiate what the power function. It's called a power function. Now, another one is, as far as this question is precise, the sine function itself, which is only belongs to a category of trig function. So to differentiate something like power function like sine x, it's a standard derivative. It is whenever you are differentiating sine x, you get cos x. Whenever you are differentiating cos x, you get minus sine x. We also have differential of tan x with it cos x. You have cos x, you have sec squared x, and so on and so forth. For as far as this is concerned, I just want to limit it to this spot in time as far as this question is concerned. So, in other words, we are going to be differentiating this individual function that made up of the whole concept of y. individually. So we're going to differentiate this individually. So I'm taking the first one, the differential of 6 with respect to x, which is actually a constant, it's a number. So whenever we are differentiating a number, we have 0. So that's how we do it. So now the next thing is to differentiate the second one, which I'm going to use another different color. Maybe then use blue this is. So we are going to use differentiate d with respect to what? The x, well, with respect to x as well. So I told you that this is a power function. Whenever you have a power on the top of a variable like this, it's called power function. So what we'll do is follow the what second rule here. It says the coefficient here is 1. Whenever you don't see number, you take it as 1. We are going to say 1 multiplied by 2 x is equal to 2 minus 1. So I haven't got this one. This one is going to be what? 2 x is equal to 2 minus 1 is going to be 1. So when to this power, x is power 1 is x. So we are going to have that 2x. So that's just down that down box. So now the next one is the third one itself, which is the function of pocket. This is why I call it function of pocket, but there are two functions there. We have the span function, which is span function itself, and then the 4x, another function. This 4x is a power function. This 4x are also the power function. Why this? It's a tree function. So it two functions, that's why I call it a power function. So really that in order to solve it, I need to introduce another word. I need to introduce another letter to make things better for us to do. So let me introduce this as A is equal to sine 4x because we are going to be differentiating it. We are going to make it two function out of. So that's why I had the function as A. So I'm going to make this function here another letter which is U. So I'm going to be having my length, my 4x now be U. So it is going to be what? 4x. So we are following. So now, so if that be the case, K will turn to sine U because I've changed 4x to U. So now, what I'm going to do is that I'm going to differentiate K, I'm going to differentiate U. So I will differentiate K in such a way that I'm going to have the differential of K with respect to U. Or with respect to U. So what I'm going to have now, I'm going to have the K with respect to U, which is the same thing as the differential of sine U with respect to the U. So which is like we're having x here, sine x, which is cos x. So we're having, I'm going to be giving us what? Cos U. That's it. That's what we're having in cos U. But when it comes to what now, power function is another second function that I want to because another law. So which is U equal to 4x. Now how do you do this one? So I'll do it somewhere here. So this one's gonna be what? Where do it somewhere here. So the U with respect to, let me change. Let's try and change the color. Wait, so the U with respect to the x, and we're differentiating the U with respect to the x. So the U with respect to the x is gonna be what? Look at it, the power there is 1 and the coefficient here is 4. So it's gonna be what? 4 times 1 x is equal to 1 minus 1. So now, so 4 times 1 is definitely 4. And then x is equal to minus 1 minus 1, x is equal to 1 minus 1. It's going to be x is equal to 0. Note that from the law of indices, 10 to the power 0 is 1. So my answer here is going to be 4 into bracket 1, which is equal to 4. So for du dx, I get 4. For the k du, which is sine u cos u. Now, what does this one mean? It means that the whole function of the x, it means the whole function of the sine 4x dx is going to be the multiplication of this u, this r. That's the big question that you need to answer. How? How? So I'm going to show you how, because this is function of function. I've changed the, look of it, I've changed this function here, right? So I differentiate k with respect to u, so that's one function. And I've changed this 4x to u. I differentiate it du with respect to x, I get 4. So multiplying this function dk with du multiplied by the du dx. They are going to give you what? Differential of sine 4x. Multiply them together. The answer that you get when you multiply them together will give you differential of sine 4x. So meaning that what? The differential of sine 4x is going to be what? 4 multiplied by cos u. So finally now we are going to have the differential of an equation going. So the differential of this sine 4x now is going to be what? It's going to be 4 multiplied by cos u. That's function of function, which means that I'm going to have 4 multiplied by cos u. And don't forget my u is 4x, so 4 cos 4x. So that's the differential of it. So I haven't got the 3 now. Don't forget, I haven't got the 3. Divided by the 3. I haven't got the differential of the 6 with the x, and you're going to have 0. The differential of this one, I'm having this. And so I'm going to have 0 here. I'm having this one here. And I'm having this one. So the differential of the whole concept here now, of the whole concept here, will be addition of my results, the whole concept here. The addition of my result, which is 0 plus 2x plus 4 cos 4x. 4 plus 4x. So my final answer is going to be 2x. Yep. 4 4x. Final. That's it. So that's going to solve this one. So there's the next question. So